Assalamu alaikum everyone. Today we will cover the second lecture of the topic differentiation of further period 2 syllabus of Cambridge Board. Here we will discuss the second derivative of parametrically defined equations. As you know that in P3 you learned how to get the first derivative of the parametric equations. But we didn't do the process, we didn't do the technique how to get the second derivative from a parametrically defined equation. In this syllabus, we will try to understand how to get the second derivative from a parametrically defined equation and then how to use that to get the nature of stationary points and other applications. So let us start with a very simple parametrically defined equation. Like if I say that an equation is defined parametrically like this, it is x is equal to t and y is equal to 2t squared minus t. Now, if I ask you to find dy by dx, how to do that? We need to find dx by dt first. So dx by dt would be 1 here. And we need to find the dy by dt here. So we will get dy by dt is 4t minus 1. Now how to find the dy by dx? Dy by dx is equal to, at the numerator we'll have dy by dt. At the denominator we'll have dx by dt. So we can put the values here to get the dy by dx in terms of t. So now we are getting 4t minus 1 by 1. So it is 4t minus 1. So we have got the first derivative. And for doing this work, we don't need the concept of FP2. We can do this thing by our knowledge from P3 syllabus. Now, we want to find the second derivative. How to do that? So we know that second derivative means that dy by dx is 4t minus 1, as you know that. From here, second derivative. Second derivative is actually ddx of the first derivative. So ddx of the first derivative. Now, our first derivative is in terms of t. It is not in terms of x or y. So it is in terms of t. Now, from the very basic of differentiation, we know that we cannot differentiate t with respect to x. It is called implicit differentiation. So what we need to do, we need to apply the chain rule like this. We will do ddt of 4t minus 1. Why t? Because the function is t here. Here we can see a function of t. That is why we have taken dt here. Now we can balance this out by applying the chain rule into, we'll give dt here and dx at the denominator. So it is balanced out. Now we can easily differentiate this. So we get 4 after doing the differentiation and dt by dx. How to get this? Look at this. Dx by dt is 1. So what would be dt by dx? 1 by 1. dt by dx is 1 over dx by dt. So it would be 1. So that means I have got the value of the second derivative as 4 at this point. So this is how we can get the second derivative of a parametrically defined equation. This was a very simple stuff. I will try to explain this sum. This is x is equal to t squared and y is equal to t cubed minus t. Again, this is a parametrically defined equation. Now, you are asked to find the first derivative and the second derivative also in terms of t. So, x is equal to t squared, y is equal to t cubed minus t. Now, I need to find the first derivative first. That means the dy by dx. So, dx by dt would be 2t. And then dy by dt would be 3t squared minus t, minus 1. Now, how to get the dy by dx? Dy by dx. To find dy by dx, we need to keep the dy by dt in the numerator and dx by dt in the denominator. So dy by dt is 3t squared minus 1 and dx by dt is 2t. So I have got the dy by dx in terms of t by applying simply the concepts that we learned from the syllabus of P3. Now, to go for the second derivative, we need to express this one in ax to the power n form, like 3 by 2 t. We are splitting this expression. 3 by 2t minus half t to the power minus 1. So if we express this one in this way, it would be easier for me to get the second derivative. Now, how to get the second derivative? What do you understand by d squared y by dx squared? This is simply d dx of the first derivative. So d dx of the first derivative. And what is our first derivative? It is in terms of t. So it would be d dx of the first derivative, that is dy by dx. Now, as you can see here, that dy by dx is in terms of t. So I need to differentiate this expression with respect to t, otherwise it cannot be done. So I am differentiating the first derivative with respect to t. Now to balance this out, I will apply the chain rule here. So this one into dt by dx. Now ddt of the first derivative here in terms of t, 3 by 2 t minus half t to the power minus 1 into dt by dx. What is dt by dx? Dx by dt is twice t. So dt by dx would be 1 over this. So it would be 1 over 2t. So if I differentiate this, this is 3 by 2 minus 1 minus, it would be plus, so half t to the power minus 2, n x to the power n minus 1. Simple formula of differentiation. Into dt by dx is 1 over 2t. Now, if we do a further simplification here, we can easily get the expression 3 by 4 plus 3 by 4t to the power minus 1 plus 1 by 4 t to the power minus 3. So I have got the expression for dy by dx. I have got the expression for dy by dx in terms of t, and I have also got the expression of second derivative in terms of t. So this is the end of this sum, guys. Now let us look at a sum from the question paper. This is a sum taken from winter 2023 and it is question number 2. You can see here that an equation is defined parametrically where x is equal to 1 plus 1 over t and y is equal to t times e to the power t. You are asked to find dy by dx, or you are asked to show rather dy by dx is equal to this. So to do this part, the concept from P3 is enough. What I need to do, I need to find dx by dt first. And then I need to find dy by dt. And then I will apply the formula dy by dx is equal to dy by dx is equal to dy by dt divided by dx by dt. And then simplify to get the desired expression. Now, let us start with x, guys. X is equal to 1 plus t to the power minus 1. Now, if I differentiate x with respect to time, I'll get dx by dt. So it would be 0 here, and here I'll get minus t to the power minus 2. So now we know the expression of y in terms of t. If I differentiate this with respect to t, I will get the first derivative. But here you can see, you have to be very watchful here. You can see that this is a product. Now, when it is a product, to get the differentiation, you should apply the product rule of differentiation. That means I'll keep t and I will differentiate e to the power t. And we know that the first derivative of e to the power t is e to the power t. Plus, I'll keep e to the power t now and I will differentiate t. Now, what is the first derivative of t? That is 1. So I'm getting this. Now, to get dy by dx is equal to, it would be t e to the power t plus e to the power t. So I have got dy by dt at the numerator and dx by dt at the denominator. So if I simplify, I get this. Now, if I take t e to the power t as common, so I'm getting like this. So to find the expression in this way, I'll take the minus e to the power t as common. Then I will get t cubed plus t squared. So this is the final expression, guys, that we were asked to show actually here. I hope you have understood all the steps because this is actually P3, the concepts of P3. Now, to find the second derivative in terms of t, how to do that? I know the dy by dx in terms of t. Now, if I want to get the second derivative, I must understand what is the meaning of d squared y by dx squared. So d squared y by dx squared is actually ddx of dy by dx. Now, as we know that dy by dx is in terms of t. So I have to differentiate with respect to t, not with respect to x. It cannot be done. So I am writing like this, ddx of the dy by dx, this one, minus e to the power t, t cubed plus t squared. Now I have to differentiate this expression with respect to t. And then I have to balance out by applying the chain rule. So I will write like this, ddt of this expression, ddt of this expression, and to balance it out, I'll have to apply the chain rule here. So it would be into dt by dx. So now here you can see that again you will have to apply the product rule to get the derivatives here. So I'll keep e to the power minus t and I'll differentiate this. If I differentiate this, I'll get 3t squared plus 2t. So it would be 3t squared plus 2t plus. Now I'll keep this one as the product. So t cubed plus t squared into, if I differentiate this, I'll get minus e to the power t into dt by dx. What is dt by dx? Dx by dt is minus 1 by t squared. Now 1 over this would be minus t squared. So this one into t squared, minus t squared. Now I have to just simplify to get the expression of second derivative in terms of t. That would be the end of this sum, guys. Now, e minus e to the power t, I'm taking minus, this minus here and here, they will make it positive. So e to the power t, I'm taking it as common. I'm taking minus e to the power t as common, and we have minus t squared outside. So if we multiply this two, I'm getting positive e to the power t, t squared. Now I will get, inside the bracket, I'll get this 3t squared plus 2t plus t cubed plus t squared. Now I'm getting e to the power t times t squared into 4t squared, t cubed plus 4t squared plus 2t. Now I can take t common, or I can keep the answer like this because they didn't ask to show. So I'm taking t as common. So it is becoming t cubed e to the power t. So it would be t squared plus 4t plus 2. So this is the end of this sum, guys, from the question paper. So now the things that I have discussed in this lecture is enough to solve any sum from this topic. What is the topic here? We have discussed the second derivative of an equation which is defined parametrically. Now you can try this sum. I have given the answer here so that you can verify yourself that whether you have understood the topic or not. But before you start doing this sum or other sums from the question paper or the book, I will request you to do the sums by yourselves that I showed in the class today. Thank you very much, guys. Take care. Assalamu alaikum.